Hey guys, so in this video I'm going to take the discussion further and discuss more questions on local max and local min from the exercise 17.4 of Mathematics for Economic Analysis by Knut, Sydsaeter and Peter J. Hammond. So first of all I'll be discussing example 17.10 and then after that I'll move on to exercise 17.4 or the problems on 17.4. So let's start now. Page 634, mathematics for economic analysis. Right, so example 17.10 says that classify the stationary points of fx comma y, and fx comma y is equal to x minus 2 e x square minus x e y minus 2 whole square. Right, so this is our question and we need to classify the stationary points of this question. So now let me write the question again once again and then we'll start solving. Right, so this is our question. So for this, now we need to find the stationary points first. So for finding the stationary points, what do? We find the partial derivative with respect to x of the function first, then we find the partial derivative with respect to y, and then we equate both of those partial derivatives to 0. So del f by del x, which is also known as f of f1, where x is my first variable, so I'll denote it using 1. Y is my second variable, so I'll denote it using 2. I discussed all of these concepts in the previous video, so watch that video and then come to this video. So after if you watch the previous video first and then you come to this video, things will be more clear to you and you will know what I'm doing here, right? So 1, now I'll be finding out fy. I just used the product rule in differentiation and I applied that, right? So ey minus 2 whole square was a constant term, because in partial derivative we only find the differential with respect to one of the variables out of the two variables or three variables, and we treat the other variable as a constant. So now my constant term will be wait, first I need to find the differential of this term. So ey minus 2 whole square as it is, and 2y minus 2 and 1. So 2y minus 2 1, and now this was the constant term. So my constant term here was x minus 2 1 e x square minus x. This was my constant term, right? I hope you guys can see what I'm doing here. Right, so I'll now equate this to 0. Right? So now I'll be equating this term to 0, and for that let's just copy this term. Now we'll find the stationary points. So the stationary point from this whole expression can be, so I'll take ex square minus x as common, and I'll be left with 1 plus x minus 2 into 2x minus 1. I think I've solved a question similar to this using extreme value theorem earlier in exercise 17.3, so please check that out. I feel this is the same question. They've given it as an example, right? So ex square minus x, 1 plus 2x square minus x minus 4x plus 2, which is equal to 0. So ex square minus x becomes 2x square minus 5x plus 3. Let me check. 2x square minus x minus 4x plus 2 plus 2 1 3, yes, along with this also, this term also, right? So right, so now 2x square minus 5x plus 3 is the only term that that can be equated to 0, right? So this whole expression can be 0 when this goes to 0, or this becomes 0. So 2x square minus 5x plus 3, so 6. So minus 3x minus 2x, 2x square minus 3x minus 2x, yes, plus 3, which is equal to 0. So 2x square, so x, 2x minus 3 minus 1, 2x minus 3 equal to 0. So x minus 1 and 2x minus 3. Therefore we get x is equal to 1 comma 3 by 2. Now I'll use the second expression, which I got by equating the partial derivative with respect to y equal to 0. So I'll just take this expression. So this was the constant term, right? So my f of 2 becomes equal to So this is already in the product form, and from here I can say that this expression can be equal to 0. This expression can be equal to 0 when my y is equal to 2 or my x is equal to 2. So these are the two additional points that we have gotten, right? So let me just check once. This was the expression given to me, x minus 2 ex square ey minus 2, right? So this was the expression given to me. Now for f of 2 what I did was, I treated this as a constant, right? And I differentiated this term e to the power y minus 2 as it is to y minus 2. Yeah, so what we've done is correct. Now moving on. So the points that I've gotten ultimately are, so I have y is equal to 2, x is equal to 2, and from here I have x is equal to 1 and x is equal to 3 by 2. So the points that I've gotten are 1, 2, 3 by 2, 2, 2, 2. Yeah, so these are the points. These are my stationary points. Now I can classify, and I have to classify them as local max, local min, and so on, right? So for finding out the local max, local min, I need to find the second order partial derivatives. So I'll be finding out this f11, which is del of del f by del x with respect to x only, which is also written as del square f by del x whole square, right? So this is my f of 1, 1, and now I'll be finding this. So for finding this, I need to differentiate this term. I need to just differentiate this term with respect to x. I need to differentiate this term with respect to x, but again I have to differentiate this term with respect to x, and again I have to treat y as a constant, right? So I'll be just copying this term. So sorry. I don't think I can copy this term. Right, so I need to differentiate this term with respect to x. So del by del x, right? Now this will be equal to, so wait a minute, I wrote this term as, I took x minus 2 x square minus x common, right? X square minus x common, and I was left with this term inside the bracket. So I can write this as 2x square minus 5x plus 3, 2x square minus 5x plus 3, yes, and e to the power x square minus x and e y minus 2 whole square, right? So this is 2, and this is del, right? So I'll treat this as a constant, so I can write this outside only. Now 4x minus 5 and ex square minus x comes as it is, then adding 2x square minus 5x plus 3 comes as it is, and I have ex square minus x, and now 2x minus 1. So again what I can do is I can take e y minus 2 whole square and e x square minus x common from the bracket. I'll be left with 4x minus 5 plus 2x square minus 5x plus 3 and 2x minus 1, right? So what I can do further is that I can simplify this term, but there is no point of simplifying this further. There is no point in simplifying this further because I already have my stationary points, and I would need to put those points inside this expression of f11 and find out the values. So I can write this expression, or let me simplify. So 4x minus 5, 2x, 4x cube. I'll be left with 4x minus 5 plus 4x cube, 4x cube minus 2x square minus 10x plus 5x plus 6x minus 3, 4x minus 5, 4x cube minus 2x square minus 10x plus minus 10x plus 5x minus 2x minus 10x plus 5x plus 6x minus 3, right? So this gives me 4x, 5x, 6x, so 10x, 15x and minus 10x, so 5x and minus 8. So this gives me 4x cube minus 2x square plus 5x minus 8. So minus 5 minus 5, 4, 6, 10, 10, 5, 15, 15 minus 10, 5, so 5x, 4x cube minus 2, yeah. So let me just erase this whole term now. I hope you guys can see me and my PDF, right? So now I need to find f of 2 comma 2. F of 2 comma 2 is del by del y f2 del by del y f of y, or del by del y del f by del y, which can be written as del square f by del y whole square, which is equal to f22. So now finding f22, what I'll be doing is del by del y. Now I'll be finding out the expression. I'll be just copying the expression from above. So this was my expression. Right, so this is f2 comma 2. I hope you guys can see me. A lot of sunlight is coming from the outside, so it is burning my skin. That's why I was trying to put a curtain over my face. So now I need to just differentiate this. So e of x square minus x and x minus 2 are constant, so they come outside. Now I have e minus 2 whole square, so this gives me 2 e y minus 2 whole square and y minus 2 and okay, so 2 also comes outside, and and y minus 2 again, y minus 2 plus e y minus 2 whole square and 1. So if I just take out e y minus 2 common, e y minus 2 whole square common, so I'll be left with, and e 2 also comes here, so 2 x square minus x and x minus 2, so I'll be left with 2y minus 2 whole square plus 1, and this I'll be leaving like this only, right? So this is my f2. Right, this is 2. So now I need to just put in my stationary points, right? So this is my f of 2 2, right, and my f of 1 1. Now my stationary points were these, right? These were my stationary points. So these are my stationary points, right? Now I need to substitute these stationary points in my expression. So f of 1 1. Wait a minute, I also need to find my f of 1 2. So f of 1 2, basically f of 1 2 is equal to f of 2 1, f of 2 1, which is del f by del x, which is del by del y and del f by del x, or it is equal to del by del x. So basically this is f of 1 2 and this is f of 2 1, right? Now I'll be just finding out this expression, this last expression that we need, and after that we'll just put the points and check which is local max, local min, etc. So now my f of 1 was, I'll be using the f12 definition. So I'll be finding out the partial derivative. Of x, first order partial derivative of x with respect to y. So I'll be getting f12. So my f of 1 was this expression was my f of 1. So I'll just So this was all f of 1. So I'll just write this again, ey minus 2x square minus x 2x square minus 5x plus 3. Right, so my expression was this del by del y ey minus 2 whole square e x square minus x 2x square minus 5x plus 3. So I need to find with respect to y. So f12 becomes f12 becomes 2 y minus 2 e to the power y minus 2 whole square e x square minus x and 2x square minus 5x plus 3, or I can also write 2x square minus 5x plus 3 as 2x square minus 5x plus 3 as, wait, I factorized this term earlier, right? So 2x square x minus 1 and x minus, yeah, so I can write this expression as x minus 1 and 2x minus 3, x minus 1 and 2x minus 3. So after we factorize we get x minus 1 and 2x minus 3. Now I need to find the values of all of these points, right? So values of all of these expressions at my stationary points, So my stationary points are 1 comma 2. First stationary point is 1 comma 2 at 1 comma 2 So at 1 comma 2, if I just substitute 1 comma 2 in f11, for that I need to write this expression again. So at 1 comma 2, my f of 11 becomes f of 11 is ey minus 2 whole square x square minus x and 4x cube minus 2x square plus 5x minus 8. So I just substitute 1 comma 2 in this expression and I get at 1 comma 2. So f of 11 at 1 comma 2. So this gives me if I just substitute 2 in this expression, I get 1, because 2 minus 2 becomes 0, so e to the power 0 is 1. Then if I substitute 1, e to the power, this is e to the power x minus x square minus x. This is e to the power. This is one expression, and this is another expression, and this is another expression, right? So again 1, and after I substitute 1 comma 2 here, I get 4 into 1 minus 2 plus 5 minus 8, which is 4 minus 2 is 2 plus 5 7 minus 8 minus 1, so I get minus 1. So f11 is minus 1. Now f22 at 1 comma 2 becomes, if I just substitute it manually, so this gives me 2 into 1 and 1, 2 into 1 minus 1, so minus 2 so far minus 2, and 2y minus 2 becomes 0, so 1, so minus 2, I get minus 2. f2 comma 2 at 1 comma 2 becomes minus 2. You can just substitute and check. And f1 comma 2, which is equal to f2 comma 1, which is equal to f2 comma 1 at 1 comma 2, this becomes at 1 comma 2, this expression becomes, if I just go to 1 comma 2, if I substitute 2 here in place of y, I get 0, so this whole expression becomes 0, and if I substitute 1 also here, the whole expression becomes 0. So f1 comma 2 which is equal to f2 comma 1, this becomes 0. So if I just now apply the conditions that we learnt yesterday in the previous video. So the conditions were, if this is my A, this is my C, and this is my B. So if my A is negative, A is less than 0, and my AC minus B square, which is minus 1 into minus 2, minus B square is equal to, this is equal to 2 positive, it is positive, so I get a local max, I get a local max at 1 comma 2. And if I draw a Hessian matrix, which is f11, f22, f21, f12, and f21 and 12 are equal, so I get negative 1, negative 2, 0 and 0. So this becomes less than 0, and the determinant of this matrix, which is minus 1 and minus 2, minus 0, minus 0 and 0, that is why we write whole square. So minus 0 into 0, minus 0 into 0, this becomes positive 2. So this is greater than 0. Hence my matrix, my Hessian matrix gives me a negative definite matrix. So this is a negative definite matrix, which implies a local max at the stationary point 1 comma 2. Right? Now we can go on and substitute the other points. So my next stationary point was 3 by 2 comma 2, 3 by 2 comma 2, 3 by 2 comma 2. So just see here, if I substitute I need to find the value of this expression. I need to just copy this expression again. 4x cube minus 2x square plus 5x minus 8. So x cube minus 2x square plus 5x minus 8, 5 minus 2 whole square. Right, now I need to check the value of this at 3 by 2 comma 2. So after substituting 3 by 2, I get 4 into 27 by 8 minus 2 into 9 by 4 plus 5 into 3 by 2 minus 8, and this becomes e to the power 0. Again this becomes 9 by 4 minus 3 by 2. Now this gives me 2, this gives me 2, so this expression becomes 27 minus 9 plus 15 minus 16 by 2. So 9 plus 16 is 25. 25 minus 25 plus 15 gives me minus 10. So this is 17 by 2. So this is 17 by 2. And this expression is e to the power 9 by 4 minus 3 by 2. So this gives me 6, 9 minus 6, 3 by 4. So basically this becomes 17 by 2 into e to the power 3 by 4, which is positive, and f11 3 by 2 I hope what I am doing is correct. So this is e to the power 3 by 4, and will be given a condition also? No, you won't give any condition. Yeah. So f of 1 comma 1 3 by 2, f of 2 comma 2 at 3 by 2 comma 2, this becomes 3 by 2 comma 2. So this gives me this. If I just substitute 2 here, I get 0. So 1, I get 1 here, so I get 1 overall, and again 2 into, if I just substitute 3 by 2 here, so I get 3 by 4, 2 e to the power 3 by 4, and minus half and 1. So this becomes 2. This becomes 2 into e to the power 3 by 4, and 2 into e to the power 3 by 4. This was 3 by 2 minus 1, minus 2, and this was, or minus 1, it should be minus 1. How did this term come? Yeah. So coming back, I just want to check something. So this becomes 3 by 2 and this becomes 1. 2 e to the power 3 by 2. This becomes 3 by 2 minus 2 and 1. My iPad is going out of battery. Need to charge it. And minus half. So this gives me minus e to the power 3 by 4. Now f of 1 comma 2 at 3 by 2 comma 2 which is equal to f2 comma 1, this again becomes 0 because I have y minus 2 term here, right? So I have 2y minus 2 term, so this becomes 0 again, right? So this becomes 0. So if I just go back, I can just substitute 0 here, right? I can just write 0 here. So if I just draw, if I just write the values, so the value of my a is, so the value of a is, the value of a is 17 by 2 e to the power 3 by 4. Value of b is minus e to the power 3 by 4, and the value of c is e to the power minus 3 by 4, and the value of b is 0 again. So this gives me my a is positive, my ac minus b square is negative, minus 17 by 2, and e to the power 3 by 4 plus 3 by 4 becomes 2 into 3 by 4, so 3 by 2, and which is negative. And we also learned yesterday only that whenever my AC minus B square, which is the determinant of the Hessian matrix, whenever it is negative, we imply that stationary point 3 by 2 comma 2 is a saddle point. Right? So now the last point, I don't know if I should classify it as a stationary point or not, because there was a condition in that expression that either of them could cause the derivative to become 0, but let's just find it out. So my last point was 2 comma 2. So if I just substitute 2 comma 2 in this expression, so f of 1 comma 1, so f of 1 comma 1 gives me 4 and x cube, so 2 cube minus 2 into 2 whole square plus 5 into 2 minus 8, and this becomes e y minus 2, so 1, and e to the power x square minus 1, so this becomes e to the power 2. So this gives me 4 into 2 cube minus 2 square, so this becomes 4 into 8 minus 8 plus 10 minus 8, so 32 minus 8, 32 so 16, wait a minute, 32, 42 minus 16, 32 and 20, 32 and 32 minus 6, 26. So 32 minus 8 gives me 24 plus 10 is 34 minus 8 is 26. So 26. So basically this gives me 26 and 26 e square, and my f2 comma 2 becomes 0. f2 comma 2 becomes 0 because I have x minus 2 term here, right? So this becomes 0, f2 comma 2 becomes 0, f2 comma 2 becomes 0, and my f1 comma 2 or f2 comma 1, this also becomes 0 because I have 2 comma 2 here, right? So you can just see I have 2 comma 2 here, right? So the value of my expression becomes a is positive, a, and this is c. So this is my a, this is my c, and this is my b. So my a becomes positive, my a becomes positive, my b is 0, my c is 0, and my ac minus b square becomes 0. And whenever my ac minus b square, which is the determinant of my Hessian matrix, becomes 0, I say that it can be either local max or a local min. The stationary point can be either a local max or a local min. And why is that so? Because my Hessian matrix turns out to be indefinite. If I just draw my Hessian matrix here, so the values that I'll be getting is 26 e square, 0, 0, 0. So my Hessian matrix h of 2 comma 2, this becomes 26 e square greater than 0, and again I have 0 as my determinant. These are my LPM. What was the full form of LPM? I don't remember the full form of LPM, but APM are my all principal minus, right? So I don't remember the full form of LPM. And this is basically my first term, which is A11, A11. This can be anything, right? A11 and A. So A and my A11 and my determinant of my Hessian matrix is, and the determinant of my Hessian matrix is 0, and my all principal minus, if I find them out also, is positive. A11 is positive, and my A22 is equal to 0, and my and my determinant is 0, and 0 can also be written as greater than equal to 0. So 0 and greater than equal to 0 are both equal because 0 is coming in both of these expressions. So I can say that this is a positive semi-definite matrix. But the question is, positive semi-definite matrix implies that it can never be a local max, but it can be a local min. It cannot be a local max, but it can be a local min. Now we have to show if it is a local min or not. So can be a local min, but we are not sure. So if I just take a point, 2 comma 2 plus delta. So f of 2 comma 2 plus delta, and I will take a point f of 2 comma 2. So if the expression that I get at f of 2 comma 2, gives me f of 2 comma 2 here gives me 0. So I have, and f of 2 comma 2 plus delta is any term which is tending to 0. F of delta is any term which is equal to which is tending to 0. So f of 2 comma 2 gives me 0, and f of 2 comma 2 plus delta also gives me 0, right? And if I just try to put in one more point, f of 2 comma 2 minus delta, this term is also equal to 0. So I can in no ways say that this is a local max or a local min, right? Because at all of these points around 2 comma 2, so 2 comma 2 plus delta and 2 comma 2 minus delta, both of these points are in the neighborhood of 2 comma 2, right? So, and these 2 points, 2 comma 2 plus delta, 2 comma 2 plus delta, and 2 comma 2 minus delta, both of these points are in the neighborhood of this point, and they are giving the same values as 2 comma 2. So I can in no way say that 2 comma 2 is a local min. If the values that I was getting were much greater than 2 comma 2 at the boundary of 2 comma 2, right? So if 2 comma 2 plus delta would have given me some value like 5 or 6 or 2 or 3, and 2 comma 2 minus delta would have given me some value like 1 or 2 or 3, something which was greater than 0, then I could have classified 2 comma 2 as a local min, right? But all of these points are giving me the same value, so I cannot classify 2 comma 2 as a local min, right? This is something which I would explain in the upcoming videos, right? I don't think this was clear to you, the last point, but I would try to explain it more. If there are any doubts, please let me know in the comments, and I'll do my best to explain this point further, right? But I explained you what is local min and local max in the previous video. Just check that video out and you will know what I'm talking about. And in that ways, when you come back to this video, you'll know what I'm trying to explain, right? So thank you for watching this video. I'll share my working with you in the link below. I'll share the link with of my working below in the description. Please check that out, and if you have any doubts, please let me know. If you find any discrepancies or errors in my explanation, in my content, please do let me know what changes I can make, or how can I fix those errors. So bye bye, I'll see you in the next video. This was quite heavy for me also.